ಸರ್ ನೀವು ನನ್ನ ನೋಡ್ಕೊಂಡು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ.
ಆಯ್ತು ಮೇಡಮ್.
ಅಲ್ಲಿ ನಿಮ್ಮ ಮುಖ ಕಾಣಿಸ್ತಂದ್ರೆ ಆಲ್ರೆಡಿ ಇದು ಆನ್ ಅಂತ.
Good afternoon to all the viewers and my dear students. So today topics which is given to me is that of modern physics. So let us try to understand the concept of this so called modern physics. Now earlier to this I would like to introduce myself, and that I am Kalimullah Sharif. I am working as a selection grade lecturer in SJ Government Polytechnic, Bangalore. Now coming to the content of so called the modern physics, that you are expected to know that what is called as the electron emissions, scattering of lights, laser and the radioactivity. Now let us try to understand why this physics is referred as so called modern physics. At the end of the 18th century, the physics was referred as what is called as the classical physics, and where there are a lot of experimental evidence were not supporting the lot of experimental evidence were not supporting to prove the so called the statement, laws or definitions. Now whereas at the end of the 18th century there are a lot of discoveries has been made, like such as a new theory like in quantum mechanics has came into existence, and whereas the Einstein theory of relativity came into existence, and all these theories as put together, then this it is been required that the so called the physics has to be renamed, and they made an up to date physics, and they hence so they have called the so called the earlier classical physics to modern physics. Now as you know that nowadays the modern ideas now which have been totally required in our day to day activities, the one of the concepts now which are being used in so called the modern physics is, that is now how best we can able to remove the electrons from the metal surface. Now because if you can look at the modern equipments nowadays, as you know in the today's world we are called as a human being if we have mobile. If we do not have mobile, I do not feel that our life will be fulfilled. So mobile has become a part and parcel of our lifetime. Now here, now what is the idea? It is not that not to use mobiles, but let us try to understand now what is been inside the mobile. Now how the current will flow, and what could be the new concept which has been used in this. So in modern physics the first idea is that now how best we can able to remove the electrons from the metal surface. So likewise now we have what is called as the electron emissions, now which will takes place from the metal surface due to the external agencies. Now here it is a rather very difficult to understand now how one can able to remove the electrons from the metal surface. So I can give a convincing explanation on how the electrons can be removed from the metal surface. Let us imagine that you take a glass of water. Now here the glass of water, it contains inside the water molecules, and there is a surface, and this surface will able to prevent the free movement of the water molecules. That means this surface it possesses certain energy. So, because this surface possesses certain barrier, surface energy, so the free electrons or the water molecules will not able to escape. Now look at this below is where the water started boiling. When water started boiling, you will find that means the heat is being imparted to the vessels in turn. This heat, it is being carried by these water molecules, and the water molecules start moving up. That means the energy gained by these water molecules is so high that they can able to break the surface and they will able to escape from the metal surface, right. The same analogy we can also apply for the emission of electrons. Now, say for example, suppose we will consider the metals as the best surface, because the metal contains a large number of free electrons. Now, it has been found that suppose if you use tungsten and you heat the tungsten to about 1400 degrees Celsius, then what happens? The emission of electrons takes place. So, here to remove the electrons from the metal surface, so we are doing some work, that means we are imparting heat, in terms we are getting out the electrons. Now, this is called as work function, and in fact this so called this work function is different for different materials. So, I will give an example. Suppose you wanted to remove the electrons from a metal like tungsten. So, nearly 1400 degrees Celsius of temperature is required. To this temperature, the tungsten becomes white and then started emitting the electrons. But usually when we talk about work function, these work functions are expressed in terms of what is called as electron volt. So, that is, so say for example, in terms of electron volt, to remove the electrons from the metal surface like tungsten, so we require around 4.9 electron volt. Then you can ask me a question, now how much this 1 electron volt stand for? 1 electron volt, it is almost equal to, it is 1.602 into 10 raised to minus 19 joules. Now, so much of energy is required. Now, this figure is been multiplied by 4.9. So, then that is equivalent to a temperature about 1600 degrees Celsius. Now, so much of amount of temperature is required to remove the electrons from the metal surface. Now, further the research has been conducted, that is, so we can able to reduce so called this work function by giving a certain suitable coating of metal oxides. Say for example, for same tungsten, if you can give a oxide coating, then immediately the thermionic work function will reduce. It is reduced to an order of 1.5 electron volts. So, that means only 450 degrees Celsius temperature is required, so that you can able to get the same amount of electrons what you are getting at a temperature of say by 1400 degrees Celsius, right. So, this is the one of the modern concepts now which has been used, so that the televisions and what is called as the cathode oscilloscope started marketing. Now, because the television was being invented earlier, it is almost 80-90 years back, and they found it very difficult to market it because of the work function. Now, sooner the research has been conducted to reduce the thermionic work function, then it is possible nowadays to market these TVs. Now, to remove the electrons from the metal surface, now we have different types of phenomena. So, basically, so there are phenomena like what is called as the thermionic emissions, now where heat is being used as a form of energy to remove the electrons. And the second phenomenon is what is called as photoelectric emission, where the light is being used to remove the electrons from the metal surface. And the third phenomenon is so called the field emission, where a external strong electric field is being used to remove the electrons from the metal surface. And finally, we have what is called as secondary emission, by means of which a highly speedy primary electrons are used to bombard the surface. In turn, we can able to get the so called the secondary emission. Now, let us try to explain what is meant by this so called the thermionic emission. The word therm, it is taken from what is called as thermal, ionic, it is charged particles, emission means ejections. Now, here just look at this. So, this is a tungsten. When this metal tungstens are heated to a certain temperature, when heated to a certain temperature, then what happen, as I told you earlier, if you can imagine now how the water molecules will try to escape when it is get heated up. In the same way, when tungstens are heated to a certain temperature, then immediately the emission of electrons takes place from its surface. So, these emitted electrons are called as thermions. The current constituted by this process is called as the thermionic current, and this entire process is called as thermionic emission. And this effect was earlier was found in what is called as the Edison bulb, and this thermionic emissions has got lot of very important applications. That is, some of the applications of these thermionic emissions are, this process is used in CRTs, that means cathode rays oscilloscopes or cathode rays tubes, now which are used in TV. And next is, it is also been used in wall diodes, wall triodes, tetrodes. So, these are some of the electronic devices. So, they are being widely used either in a transmission station or in a receiving station or in a certain X-ray tubes and all this. Now, let us consider the second effect. So, that is the photoelectric effect. Again, this name itself implies the photo means light, electric means current, effect. So, that is the combined effect. That means, so it was the Hertz in the year 1887. So, he found that when certain metals surface are incident with light with a suitable frequency, it is called as the threshold frequency, then what happens, instantaneously there is electrons are liberated from the surface. The electrons which are being liberated from the surface by this process is called as photoelectrons, and this phenomena is also referred as what is called as photoelectric effect. So, this phenomena usually it is based on the quantum mechanical ideas, where whenever certain radiations, when they try to interact with certain substance or matters, so then what happen, the photoelectrons are produced. The materials which are being best suitable for this type of phenomena, the metals usually belongs to a group called as alkaline groups. So, where the alkaline metals are used, say for example, potassium, sodium or selenium, etc. Now, here is how the phenomena of photoelectric effect will takes place. It was been completely explained by Einstein. So, what according to Einstein, so this effect has fetched him a Nobel Prize, and according to Einstein, now he says that it is totally based on quantum theory, that is what we call light. According to Einstein, he said that it is not light, it is made up of a quanta. That means, what is a quanta? Now, quanta is nothing but energy packets or the energy bundles, and this quanta energy bundles, it will have an energy is equal to h into nu. So, I will try to explain this, that is the energy of the photons. Let us imagine this is the metal surface. When this metal surface is irradiated with certain radiations, that is, these are the photons, and the energy of the photon is given by h into nu, where h is called as the Planck's constant and nu is called as the frequency. Now, as this metal surface, it consisting of free electrons, let us say 1, 2, 3, 4 and so on, they are the free electrons. Now, what actually happen is, once the photons now falls on a, say for example, on a electron number 1. Now, the question is the energy of this photon, it has been completely absorbed by this, the mark number 1 electron, or whether this will able to release the energy. See, what happen is here is, whenever there are 2 electrons are there or the 2 particles are there, then what happen is, so this the energy of this photon is completely absorbed by this particle, or the energy of this has been completely absorbed by the particle number 2. Now, here the sharing of the energy does not takes place. So, that means this energy h nu, the energy of the photon, now it has been utilized in 2 different ways. That means, once the photon hits the particle number 1, then the energy of the photon is been completely absorbed by this particle, then it will try to escape from the surface, right. So, that means, as I told you, to remove the electrons for the metal surface, now we have to do some work, that is called as the work function. Let phi is the work function here. That means, the part of the energy of the photon is being utilized to remove the electrons from the metal surface. So, that is the phi, and the next part of the energy will use to remove the electrons outside the metal surface. That means, it has to escape from the metal surface. That means, when it escapes from the metal surface, it should possess a lot of kinetic energy. So, that means, the energy of this photon, it is been divided into 2 parts, that is phi plus the kinetic energy. So, that means, h nu is the energy of the photon, this is phi is the work function, plus it is half m v square. So, this expression is referred as what is called as the Einstein photoelectric expression. So, this expression is being used to understand, that is what is the amount of energy which is being required to remove the electrons from the metal surface. Now, so called this phenomena, that is so called the photocell, as we know that here it is a device now which will convert the light into the electrical energies, or we can call it as electrical signals. So, this photoelectric effect, so it is further, it has been put into different photocells. So, there basically there are 3 types of cells. So, that is the one type of cell is called as the photoemissive cell, a photoemissive cell we have. The second type of cell is called as a photovoltaic cell, and the third type of cell is called as photoconductive cell. Now, let us try to understand what is this photoemissive cell. Now, just look at this diagram. So, here, so you have a highly evacuated quartz bulb, it is totally a vacuum bulb, and here which consisting of 2 electrodes. So, that is one is a cathode, and this cathode is a photosensitive material, this cathode is a photosensitive material. So, where the alkaline metals are being coated on it, and encircling to this cathode. So, there is a thin hair like wire, either it is made up of platinum or nickel, is all depends upon the type of application. It encircles the photocathode. Then the other end of this photocathode, it is been connected to the negative of a battery. The other end of this the anode is been connected in series with a galvanometer or an ammeter in series, then it is been connected to the positive of a battery. Now, how does it works? The working principle of this is, whenever the incident light falls on it, so as I told you earlier, if this light, if it is possess what is called as the threshold frequency, if it is possess a threshold frequency, then only the emission of electrons will takes place. If the incident energy is less than that of the threshold frequency, then emission does not takes place. So, that means, so let it be of any source, whenever the light falls on it, if the light possess threshold frequency, then only the emission of electrons will takes place. These emitted electrons, further it will travel, because it is negatively charged particles, it will travel towards the anode, and the anode will get attract this, and as a result the galvanometer and ammeter will show deflections. And this process is so instantaneous that as soon as the light falls on a photocathode, immediately there is an emission of electrons takes place. So, whereas in case of so called the photovoltaic cell, this name itself implies that in this cells we can able to generate a voltage. So, this cell now which consisting of a solid copper block, and this copper block on the top of it, it consisting of the oxides of the copper, it has been coated with this, and further on the top of it, so there is what is called as, so there is what is called as a thin transparent, there is a thin transparent layer, either it is made up of gold or silver, it has been placed over the copper oxide, and the two ends of these blocks, they are being connected to a device, say a galvanometer. Then now how does this functions? So, this works when the transparent surface, it has been exposed to radiations. If the radiations falling on it, if it is possess a threshold frequency, then immediately, and these radiations will enter through this transparent surface, then it falls to this oxide layer. Now, from the oxide layers it brings the electrons, then the electrons will be knocked out from this oxide layer and they travel towards the upper surface, it travels towards the upper surface, and that will constitute a current into the external circuit. So, the galvanometer or the ammeter will show deflections. Now, that means, now in this case, whenever the radiations, if it is false, that means these radiation will be converted to electric current. So, that means this itself is a source of energy, and this the photovoltaic cells, which are widely used, you might have seen that this kind of cells which are used in case of emergency lights, where you have a big solar panels are used, even where at the remote places where the electricity is not been made possible, where this kind of the cells are being used for the lighting systems. And the next type of this is called as the photoconductive cell. Now, here this device, it is purely based on the conductivity, that is as the light falls on semiconductor, the conductivity of the semiconductor, it goes on changes. So, that means, now here this also consisting of a semiconductor layer, where if the light, external light, if it is possess a threshold frequency, it falls on it, then what happen, instantaneously its resistance goes on changes. As the resistance goes on changes, so there is a emission of electrons will takes place, and there is an external battery is required here to attract this. So, this is not a source of a battery, but an external battery is being required to attract this. So, this whose conductivity goes on changes with the types of the incident radiations. Now, so this photoelectric emission, it follows certain laws, that is this process. This process is totally instantaneous process. What do you mean by instantaneous process? That means, as soon as the incident light, if it is falls on it, instantaneously, say within 1 nanosecond, that is of the order of 10 raised to minus 9 second. So, there is an emission of electrons takes place. Whereas, in case of the thermionic emission I told you, so there the metal has to be heated up. When the metal attains a certain temperature, then immediately the electrons will be released, but that is not the case in this case. In this case, as soon as the light falls, immediately there is an emission of electrons takes place. So, that is the reason in your house, if you switch on the television, so immediately you can't able to see the picture. So, you can hear the sound, and later on the picture comes. The reason is, so there that so called the television tube, it itself a modified version of a wall diode. So, where there is a filament in the back side, and that filament will get heated up. As it heated up slowly, then it pumps the electron. That means, whatever the picture you are seeing on the screen, it is nothing but the electron. So, that is the difference, whereas in case of thermionic emission, whereas here it is instantaneously, all of a sudden the emission of electrons will takes place. So, whereas the second concept, second law is the photoelectric emission takes place if the incident light possesses minimum threshold frequency. As I told you, let the light could be of any source, whether it is a light is a visible light or an invisible light. If the light possesses the minimum requirement, that is the threshold frequency, then only emission of electrons will takes place, otherwise no. And coming to the third is, the photoelectric current is directly proportional to the intensity of the light. So, that means, as the intensity of the light increases, the photoelectric current also increases. And finally, the energy of the photoelectrons, that is the electrons emitted due to the light. So, their energy increases with the increase in frequency, not with the intensity of the light. So, these are the certain losses which governs the photoelectric effect. Now, coming to the applications, the photocells, you will find lot of interesting applications. Nowadays, they are used widely. They are used in certain engineering applications, and they are also being used certain entertainment electronic devices. Now, here the certain applications we have given here is the photocells which are being used in TV, camera, that is in fire alarms, in burglar alarms, in automatic switching off of the street lamps, and the reproduction of sound in cinematography and so on. So, that is, so when you go to certain commercial establishment, say for either it could be a big hospital, or it could be a lift, or it could be a commercial establishment. So, there what happen is, as soon as you approach, immediately the doors are open. Now, what is the concept they have used? The concept there what they have used is, so let us imagine you have gone to a commercial establishment, these are the doors. Now, here is, so one side, so there is a photo cell is been placed, these are the photo cells. Now, photo cells which are been sensitive to infrared, and other side the light is been allowed to pass through like this. So, a light traces on this, these are the light, it falls on it. As it falls on it, so there is a what is called as electromagnets are there on other sides, and this electromagnet it will not generate any magnetism. As soon as somebody cuts, somebody wanted to enter, as it enters he is cutting the light, as it cuts the light immediately this will get energized, as it get energized it will try to pull and the doors are open. So, once he goes inside, again the ray of light will retrace, that means, so this will de-energize, again the doors will push back. So, this is the actually concept which has been used in the commercial establishment. So, it is not the one. So, there are many applications of the photo cells which have been used. So, even the photo cells has been used in newspaper factories where they try to count the number of papers. Earlier they used to use mechanical devices, and these mechanical devices will get wore out. Now, they are using this photo cell technology. Even nowadays if you go to the bank also, in the counter you have the money counting machines, where the photo cells are being used to count this the notes and all that. Now, so these are the two methods by means of which you can able to get the emission of electrons. So, there are further process by means of which you can able to get the electron, that is there are two more processes, is that the field emission. So, here in case of the third type of emission of electrons, so where you have a conductor, this is a conductor, a metallic conductor. Now, here an external field, this is an external field, say for example, a positive external field is applied. So, suppose if the distance between them is say about 1 centimeter, so nearly 1 million volt, 1 million volt positive is been applied. As such a huge magnetic, huge electric field is been applied, then whatever the electrons which are been present in the surface, all these electrons it has been pulled. As a result, all the free electrons you can able to collect it this side. So, here an external field is been applied to remove the electrons from the metal surface. So, this process in this is what happened, there is no external heating, something like that. So, no heating effect will take place, and whatever the electrons they are generated. So, this process also called as the cold cathode emission, is also called as cold cathode emission. So, this is one of the way by means of which we can able to remove the electrons. And finally, we have the last type is, that is the secondary emission. Whereas, in case of secondary emission, let us say for example, this is the electrons which has been already released. If this electron, if it is falls in some other metal conductor, and this speedy electrons as it falls at this metal conductor instantaneously. So, there is what is called as the secondary electrons are generated. These are the secondary electrons are released. So, this effect is called as secondary emission. So, these are the certain methods by means of which we can able to generate what is called as the electrons. And whereas, this field emission, so where a huge amount of electricity is being required, as I told you, if the distance between the conductor and whereas the applied field, if it is merely 1 centimeter away, then nearly 1 lakh volt is being required. It is a very difficult process. Now, whereas in case of secondary emissions, there are certain, say for example, in case of the X-ray tubes, whatever the X-ray you are obtaining, it is because of the secondary emission. So, these are the 4 important types of electron emissions which takes place in the almost in electronic devices. Now, now coming to electron microscope. Now, let us try to understand what is a microscope. As you know that a microscope is a one, so through which if any object which has been not seen with our naked eye, then we can use a microscope to see it. So, we have different types of microscope, like we have a simple microscope, like we have a compound microscope. So, usually in a conventional compound microscope, when you go to the certain clinical laboratories, so you can able to see that compound microscope which consisting of certain lenses and the light. So, where you can able to see the object which cannot be seen with your naked eye. Now, suppose if the objects are not at all seen and it is so minute, like say for example, now one wanted to observe what is the interior of the cells, what is the total composition of the nucleus, or say mitochondria, or one wanted to observe the atomic structures and all this. So, we can't use the lenses or the compound microscope. So, where we use what is called as a special type of microscope, it is called as the electron microscope. In a electron microscope, we do not use light. So, where the electrons are used. Now, the question is why the lights is not used in a electron microscope. Now, here we define what is called as a resolving power of a microscope. What is meant by the resolving power? Resolving power means it is the power of a microscope to identify two objects which are closely lying. If the two objects are so closely lying, if you can look through, that means these two objects are seen separately. So, that means how much separation it can generate. So, that is based on what is called as the resolving power, but it has been found that the resolving power of a microscope, it is inversely proportional to the wavelength of the light used. Now, whereas say for example, in case of the compound microscope, which is used in the laboratory, where we use a visible light, that is the light we use, light from a tube light, or it could be an ordinary light, where the wavelength of that ordinary light is about 500 nanometers. Now, further, and you say, as told you, the resolving power, it is inversely proportional to the wavelength. As the wavelength comes in a denominator, if the wavelength goes on decreases, that means the resolving power, the ability to see the object clearly increases. So, hence, so we use the electrons whose wavelength is very, very small, or else we can also use, we have a visible light of very shorter wavelength, even sometime we have a invisible light, say for example, ultraviolet light whose wavelength is very, very small, but we can't use ultraviolet light because we have to see the object through the microscope and it will cause damages to our eye. So, hence we use what is called as the electrons. Now, you can ask me questions. Now, how can these electrons which are being charged particle, how can these electrons can able to see the objects? So, this is purely it is based on the quantum mechanical idea, according to what is called as a de Broglie theory. According to de Broglie, he has explained that the electrons, it behaves like a wave in certain conditions, though the electrons who does not have any rest mass, but it behaves like a wave. Now, based on that idea, when these fast electrons, if they are been accelerated at an voltage of nearly 600 kilovolts, then the wavelength of that electron, it comes to about 500 picometer. Pico stand for 10 raised to minus 12. So, this wavelength, it is 1 lakh times less than that of the visible light. So, thus using this electrons as a wave, so the resolving power it is increased, and this is the concept which is we have been used in electron microscope. The basic principle of an electron microscope is very, very simple. Now, once what happened see here, this is the electron gun which consisting of a tungsten filament. Now, on other sides there are magnetic lenses are there, and these magnetic lenses which condense the electrons which has been coming out from this, and that means these magnetic lenses it is almost act as a condensing lens which has been used in a compound microscope. Now, the purpose of this lenses in a compound microscope is that, so whatever the lights now which falls from this surface, and all this light will be either converge or diverges in a same way. So, these electromagnets on either side. So, here a electric field is been applied, as a result these electrons which are being negatively charged particle, and this negatively charged particle further repelled by these condensing lenses. As get repelled, all this will get collected at this point. At this point where all the beams of the electrons will get collected, so here the specimen is being placed, and further this the fast moving electron as it falls on this, it will get diverge from these two beams, and here the further the divergence it is acceleration is being done. So, as a result, so the image will be totally seen on a fluorescent screen as it is seen in a eyepiece which is being used in a compound microscope. So, this is the concept of using the electromagnets to either to diverge or to converge the electrons which has been used. As a result, even a small object though which cannot be seen with our naked eye, it can be seen. It can be seen in the sense it can be seen in not with the naked eye, it can be seen through the image which is being formed, either the image in form on a fluorescent screen or the image is being formed on a X-ray film by observing the structure of the fluorescent screen or the X-ray screen. So, one can able to see the image of the objects. Now, so again we have one more microscope, that is called as the atomic forced microscope. Nowadays, this is one of the powerful tools in the hands of the engineers. So, this microscope it not only use the detailed structure of the surface, but it will use an idea what could be the nature of the surfaces. So, that means this consisting of a cantilever, a simple cantilever tips are there, where diamond tips are there from one side. So, the light is been allowed to fall through, and this cantilever is been slowly moved on the surface whose sample is to be studied, and later on see if the surface are rough enough, and this cantilever it moves in a zigzag way. As it moves in a zigzag way, the light which has been falling from this, it will get reflected. So, the reflected light will be observed. So, by knowing the reflected light, one can able to study the nature of the surfaces. Now, this so called the atomic force microscope, as I told you, it is one of the powerful instruments in the hands of the scientists nowadays. It not only studies, even this instrument is used to force the electrons, which force the atoms which are being present from one point to the other surface. So, this has been largely used in what is called as the nanotechnology. So, because of this instrument, so one can able to see that if the electrons are the atoms are crowded on one place, and these atoms can be further, it has been forced, as a result of it the space occupied per unit area will reduce. So, this, and nowadays the atomic force microscope, it is widely used in nanotechnology, and this has got certain important applications, that it is used to understand the biological samples like the structure of the cells and what are the aberrations, adhesions, cleanings and corrosion, etching, frictions, they are widely used. So, now so these are the concept which are given to you. If any, because as you know that whatever I explained based on this if got any feedback you can send to us. Now, because you can see me, I can't see you. So, next time when I meet you, if any problems which are not understood, so you can send us the questionnaires. So, if you got any problem, we will try to clarify. So, have a good day. Now, please take care. Thank you.